quantum computers that could one day break Bitcoin or save it. If you've ever wondered what it takes to simulate the universe, rewrite computation, and potentially reshape the future of cryptographic security, this is the guy. So let's give a big blockchain report welcome to Isaac H. Kim, everybody. Isaac, welcome to the show. We are excited to have you, and so is our studio audience. How are you this morning?
Good. Thanks for having me.
Oh, the pleasure is all ours, Isaac. Before we get into the goods, for our folks at home that might not know of your work yet, could you give us a little bit of your background? How did you get into quantum computing, and what drew you to focus on building reliable quantum systems?
I started off in this field as a PhD student, like most people in our field does. And one thing that drew a lot of people into this field was the prospect of quantum computing, doing computations that we can't do currently. And it became very quickly clear from the early on that the biggest problem for building a big, large-scale quantum computer that's useful for something is to build a reliable quantum computer. So that's why I started to focus on that.
Very cool, very cool. We're super excited to talk with you about it because we know quantum computing and Bitcoin are seeming to be at a head-on collision, and we're not really sure what that means going forward, so we're happy to have you to kind of clear some of that up for us. So I guess that kind of means let's start at the beginning here. In layman's terms, what even is quantum computing, and what makes it such a game changer compared to the regular computers that we're using right now?
Right. So quantum computer is a new type of computer that harnesses the power of quantum mechanics. The usual computer that we use just use classical physics for the most part. So like the information is stored in terms of 0 and 1. Quantum computers store information in what people call as quantum bits, so-called qubits. And surprisingly, this lets you do computations that are exponentially difficult on a classical computer. This doesn't mean that it's good for everything. It's known to be only good for very specific tasks. Like one thing is, for example, breaking Bitcoin, but more positively, simulating a lot of quantum materials is exactly what quantum computers are good for.
Interesting. And in respects to Bitcoin, you've gone on record saying that the risks to Bitcoin are real in the long term. Can you give us kind of a gut check on what that timeline looks like? Are we talking about 10 years out, or could this sneak up on people a lot faster than we think?
Right. So that's a very interesting question for obvious reasons. And the fact of the matter is, even for the experts, it's not so clear what the exact timeline will be. However, I wouldn't say the possibility of this happening within 10 years is so negligible that we should totally ignore it. Because the fact of the matter is the progress in quantum computing has been going very fast at a pace that is much faster than I certainly expected. But at the same time, I would say I would be very surprised if there's any risk for Bitcoin within the next 5 years. So I expect there to be a lot of progress in building a intermediate scale fault tolerant quantum computer that's useful for some scientific tasks. But those computers will not be large enough to crack Bitcoin. So I would say certainly more than 5 years, and it's a conservative estimate would be that we'll need at least 10 years, but the probability of happening within 10 years is small, but not totally negligible.
Okay, so I've got 5 to 10 years before I'm crying into my cold wallet. Good to know. And you mentioned it could crack Bitcoin. What does that actually mean? Are we talking someone being able to steal my sats out of random wallets, or what does that actually mean in practice?
Yeah, so for most people, you don't actually have to worry about it too much because there are actually two layers of protection. One is using public key crypto system, and the other using basically hashes for which the quantum computers are known to be not useful at all, really. Only if you use these like super old wallets that were only protected by like elliptic curve cryptography, then you should probably move that to a wallet that has like a double layer of security. But for most people, this is not a super serious concern. And moreover, well, I'm not an expert on crypto, to be honest, but my impression is that there is a movement for making Bitcoin, a future version of Bitcoin, more secure against quantum attacks. So as long as that is still going, I think for everyday people, one shouldn't worry too much about this.
Okay. And what is it about Bitcoin that makes it more vulnerable than people might think? Is it because it's open source, or is it just a cryptographic sitting duck? Like what's going on there?
Yeah, of course, like it's not just Bitcoin, but also like Ethereum, for example, that will be like vulnerable to
Hmm.
attacks. Like a lot of uh, uh, cryptos that are based on elliptic curve cryptography or RSA. I mean, they almost never use RSA, but in this setup, but any setup like that is vulnerable to quantum attacks, and this does include the banks. But what makes this particularly dangerous for cryptos is that, for example, for commercial banks, if they want to upgrade their crypto system within a year, I mean, that would be challenging, but it would be definitely doable because maybe the CEO will just give a direct order to update everything, and like everybody will have to follow that. For cryptos, it's not so clear how fast this can be done because there seems to be a need to consensus to make these kinds of major updates. And so there is a worry that, maybe there is a surprise progress in quantum computing, and maybe we're only, let's say, 3 years away. I mean, in the future, let's say we're only 3 years away from building a quantum computer that can crack pretty much all the known cryptos in the world. Like, is that enough time to actually update everything we have? That I'm not so sure actually. So that's the main thing that I'll be concerned about.
Interesting. And you brought up something I wanted to touch on too. You mentioned traditional banks, and I've seen on the Twitters and whatnot, people are saying, well, if quantum computing becomes this thing that can crack Bitcoin, why wouldn't it just be able to crack traditional finance first? And is that because of what you mentioned that JP Morgan, Jamie Dimon could issue an initiative, they could act on it quickly, but because of the open source nature of Bitcoin, it'd be a lot more challenging to update the network to defend itself against quantum computing?
Right. I think that's one thing. And another thing is that, like for some wallets, we don't know like who that wallet belongs to. So there's a certain sense of anonymity compared to traditional banks. Like even if you steal something from traditional banks, I think like with the centralized database on who had what, like some like history of what happened, I think it's reasonable to think that one can like restore the funds somehow. But with Bitcoin, obviously, this is just not going to be possible. So that I would say that's another potential issue.